going to give you a real quick rundown today on the classification of matter. Just in case you still don't get it from class, you're having trouble with the homework, just going to give you a quick rundown here. So classification of matter, we have four different categories here, the first of which is an element, okay? Elements cannot be broken down, okay? Or I shouldn't say they cannot be broken down, but they're the simplest form, okay, of something. In order to find an element, all you have to do is real simple. You just look at the periodic table. Things like oxygen, nitrogen, uranium, all of those are elements, okay? Now, the reason why I say it's the simplest form, and originally said it can't be broken down, it can, but that's nuclear chemistry. If we break down an element, that's nuclear chemistry, nuclear bombs, nuclear power plants, break down uranium, a lot of energy. So that's why you're not going to be breaking down elements unless you have or want crazy energy. The next thing are compounds, which hopefully you know what a compound is. A compound is a combination of two or more elements. Okay, so you have, for instance, things like water, H2O, right? Carbon dioxide, CO2. Oops. There you go. You know those very well. But the key about compounds, you can break them down, all right? We can split apart water into hydrogen and oxygen. We can split apart carbon dioxide into carbon and oxygen. Compounds can be split apart and broken down into a simpler form, but they are together as is. Simple, once again. So the next thing, we have to talk about mixtures. We have heterogeneous mixtures, and we have homogeneous mixtures. And I probably should have put homogeneous mixtures first, but that's okay. A mixture is a blend of two or more kinds of matter that retain their physical properties. Okay, so they remain themselves even though they're mixed together. For instance, in a homogeneous mixture, an example of that is salt water. Okay, now homogeneous means it's the same throughout. You can't tell the difference from one part to the next. You have salt water, you can't tell which parts are salt and which parts are water. It looks the same throughout, but the two things still retain the properties. The salt's still salt, the water's still water, they're just mixed together. Another example is Gatorade, okay? Gatorade looks the same throughout, but it has different things in it. That is a homogeneous mixture. Heterogeneous mixture is something like soil, okay? Soil, you take up a whole bunch of dirt in your hand, and you can tell the difference between the things, but it's still mixed together, all right? Raisin Bran, your cereal and milk in general, that's a mixture, but that's really all I have to say about that. If you have any more questions, let me know. Pretty simple if you're having problems. Oh, wait, one last thing I got to talk about, homogeneous mixtures. Sorry, this is important. I don't know if I spelled Gatorade right. We have things like brass down here. Now, this is hard because brass is a mixture of metals, all right? You have zinc and copper mixed together for brass. Steel is iron mixed with something. We also have bronze, which is tin and copper. So you have these metal mixtures. If you play a brass instrument in band like trumpet, you know that you can't tell the difference between the zinc and the copper, but it's still a mixture. So that is technically a homogeneous mixture. Now, last thing before I go, homogeneous mixtures are also called solutions, all right? So if you have salt water, it's a saltwater solution. You can use them interchangeably. So that's all I have to say. We will talk a lot more about these type of things later. Alloys are what they're called. But for now, I think this is good. Like I said, let me know if you have any questions. Cool beans. Bye.